Hello, my name is David Bate. I'm CEO of Scoptic, and I'm very pleased to be with you today at the Global XR conference. For our company, it's a very new presentation for our small form factor full vision eyepiece for XR. So our company has three activities. The historical activity from 2011 is optical design, research and development. So we mainly work for companies who want to externalize their research and development in optical design. And since almost 10 years, we have a division which deals with recruitment. So we are doing headhunting on manpower in the field of engineering and technology. And yes, from this year we have Tarsi Optics. It's the name of our business unit for this new full vision eyepiece technology. So regarding Scoptic, so as said before, our activity is research and development in optical design for companies who want to externalize this activity. And so our specialty is eye image projection. We were working since the creation of Scoptic on head-up display and mounted display for aeronautics, and now since almost 10 years we are working in the field of virtual reality headsets, XR headsets, optics. So more details about what we do. So we work on optical design, innovative optical design. So usually the people want for their optical systems more field of view. It's often number one request. With also more image quality. Also, it depends on also compactness, weight may be very important for some application. To bring innovation in the field of optical design, of imaging optical design, and imaging projection in eye. We have some some innovative know-how in using, in creating some new kind of optical surface, which could be structure surface, spatial geometry surface, freeform surface, and which are very specific on which are not available in optical design software. We really create them ourselves. We design them, and we make also some analysis on see what it can bring for the application. And then once design is done, once we have achieved some interesting steps, we do also some prototyping and testing in order to evaluate the lens, to see what could be improved, what works, what is not working, and so we have also this included in our know-how. A few words about profile optics. So it's an enhancing manpower. So for optical system on all kind of engineers for optical systems. So this means that we provide some optical engineer, mechanical engineer, electronics engineer, and also system engineers. Regarding tertiary optics, so we come back to what interests us today. So we have developed since almost 5 years of research development new technology for having an eyepiece very compact and very wide field of view. The display could be 3, 2 inch, even less. On the full vision, it could be, for example, 180 degree. So this is what is the target on what is realized at tertiary optics. So the application of wide field of view, our wide field of view eyepiece. One main application is the application of XR headsets, because it's compact, but also it's light, on wide field of view is very desirable for an immersion, a real immersion, not to be like in a tunnel, so really to open around. But there are also other possible application for our full vision eyepiece. So wherever there is some eyepiece needed, some in telescope, in binoculars, also for screen magnifiers, so other possibilities too. If we come back to XR headsets, so here I give some illustration of what we are doing. So there's two things which are important. The field of view and the display size are two important things. Field of view to know what you can get in terms of vision, in terms of immersion. On display size, it's one important factor, not only the only one, but it's one important factor for the compactness. So, for example, with our tertiary optics eyepiece, we might be able to do from 5-inch display, 180 degree field of view for XR glasses. So here you use only one display, yes, for both eye, or you may want to do some 180 degree, but not with one, but with two display of 2-inch, for example. So this is some kind of customization depending of what is needed. So just a little comeback about these two parameters which are very important. So the field of view, the size of the field of view on the size of the display. So if we come back more than 100 years ago, with the beginning of cinema, yes, maybe today at cinema you might have some 50 feet screens. and depending on where you are, you might have a 90-degree field of view. And then in 1941 we see some TV commercially, and here with some TV you might have 50-inch TV with 45 degrees field of view, depending on the distance you are, of course, for some recommended distance. And then in 1975 we see arrival of personal computers. And so it could be 20-inch personal with 45 degrees field of view. And again, we decrease the screen size with the arrival of tablet, more recent, 1989. And you have 10-inch tablet. We can provide you a field of view of 35 degrees. And again, we have decreased the screen size with a smartphone arrival in 1994. 6-inch smartphone, for example, will give you about maximum 30-degree diagonal field of view. So it's very interesting to see what is the evolution there of field of view on the side of screen, and we'll see just afterwards that we will have a breakthrough with the arrival of XR headsets. So what we see here is that with time, yes, we have smaller and smaller screen for the reason also that we gain in mobility. So the screen now could be held in the hand. And the mobility improves, you can work with it, and also the level of interactivity, the functionalities also is more and more important, so very interesting. But yes, we see also that because the field of view decrease, the display size decrease, we start to see also decreasing more and more of the field of view. This is because of the near point limitation from the eye vision. When we read, when we look at something, at a screen, at a book, we have to have a minimum distance of about 10-inch for clear vision. So that's why when we continue to decrease the size of a screen, the thing is that yes, we also decrease the field of view. So now we go to this new kind of device, which is XR headsets. So XR could be virtual reality, mixed or augmented reality. So here we focus about virtual reality, of course, but also mix on augmented reality. Which video based. Okay, and so we have for XR headset are very interesting because now you don't have anymore to hold your screen like a smartphone or tablet. Now you can wear it on your head. So the level of mobility is even better because you have, for example, your hand free. And moreover, yes, you have also this thing that when you move the head, it moves your vision. So you have also an increase in functionalities possible. So XR headsets, there is two ways to create a field of view. In fact, there is the classic way, the direct screen view that we have seen before. Where you, with your eyes, you see directly the screen, and we know now there that we have this near point rule. So you have to have a minimum distance of 10-inch. So if you want a wide field of view, you have to have a big screen. And not easy to have a big screen in a headset. So this means bulky headsets. And then there is another kind of display which is possible in XR headsets. It's the virtual screen projection. So this means that you don't look anymore directly at your display, but now you look at it through a lens. So this is very, very interesting because thanks to the lens, the near point limitation is not anymore an issue. And so you can bring your display nearer from your eye. So this is first point. The second point is that the lens magnified the screen in a very large, in a big virtual image, and so you are able now to improve the field of view thanks to the magnification of the lens. So yes, those are two interesting example of direct screen view XR headsets. So it was 2006, 2015 with 3D head on the Toshiba bubble helmet. So here to have some large field of view, to have some larger field of view than smartphone, they have to have also a larger display. So for 3D head, they use a 10-inch tablet. In fact, you get 45 degrees at 10-inch near point distance with that. And for the Toshiba bubble helmet, you have a screen projected on the helmet with an image size of about 16-inch, so at a distance of 10-inch, we should give you about 80 degrees. So yes, so we see, okay, we can make some field of view, but we have to have it big, the headsets. And also, yes, it could be also heavy. So now we look at what kind of virtual screen projection we have for XR headsets. So this is the typical way XR headset works. So with some kind of lens on some kind of displays between on the lens between the display and the eye. So we have some quite compact headsets, very compact, small field of view, but with limited field of view. Yes, maybe about 70 degrees, and the display could be quite small. Maybe you might find some display less, two display less than 1 inch for one headset, so one per eye. And next to this, there is the most common standard 90 degree or 100 degree field of view XR headsets. And you can use typically a 6-inch or a 5-inch display for one display for both eye. I think Quest 2 is like this. And but you can also use more commonly two display, one per inch, which could be 3.5, 3-inch each of the two. And now we even find some smaller display, 2.inch, 2 is coming to 2-inch. And next to this, there is a larger height field of view headsets where you might. So here there is less headsets. In fact, we have two examples there of this kind of headsets. There is where you can use two display of 5.5 inch, for example, to give you something more than 150 degree field of view. So for example, we have the X-Style 2020, which was claimed 180 degree horizontal field of view. And you have Panoramic 2019, which claimed 54 degree horizontal field of view. Now we look a little more as those existing high field of view headsets. So at this two headsets that we've seen before, so the X-Style and the Panoramic. So what we see there is that we have they have both the same architecture. It's architecture with two large display here, 5.5, and also there are some tilts of the optics on the display. So we will see this with afterwards. So we speak about canted optics, optical architecture is the way they have chosen in order to expand the field of view. So let's go next. So what could be a desirable form factor? So yes, so here we see some very recent release product or announcements about very compact headsets. So we have this HTC Flow on the left, 2020, which is interesting, with 100-degree field of view on the diagonal, on with two display of 2.1 inch. And we have also not released but announced in 2022 the Shift Fold, which about 95-degree field of view claimed, and using two display of 1.3 inch. And we have very recently released a product, the big screen 2023, which about 100-degree and using a small display, two display of 1 inch. Thanks also because they are customizing the headset to the face of the user in order to limit the exit pupil size of the headsets. So yes, we see that this kind of size is more desirable. It's more compact. We are nearer from glasses. So yes. It's a good direction to improve the aesthetic of the headset on the comfort. So now I will present you the different kind of high field of view optical architecture headset we might find. So we have already seen. So we have the standard architecture, it's architecture A on the very left in the drawing, where we have about 90, 100-degree field of view. And then we have already seen this B architecture, the tilted display on the tilted lens, so which is used in the two release products we have seen before. And then we have also the C and D, which it's some kind of optical architecture which has been presented, but with no release product yet known. So it's the multipath architecture, or also called the light field. So you might use different optics on different display, and so you have different optical axis for one eye. And also the D is that you curve the screen, and you can curve also the lens. It's another way also to try to get some very wide field of view. So what is interesting is that here those B, C, D architecture, and we can also create new architecture with a combination of B, C, and D. There are different options. So those different architectures are in fact some tricks in order to make a wide field of view, for example, a 180-degree field of view, without having to deviate too strongly the maximum ray at the edge of the display, because this is an issue to get a picture when you have to have a very strong deviation of the rays. So the image quality will not be good, and you will create a lot of optical aberration. So the counted optics, so you see it there with this Pimax picture. So you see this little drawing in the middle of a sketch, this little sketch in the middle of a slide, where you have we write what is the ray deviation. The ray deviation is this angle which of a ray which at the maximum field of view, the ray which here it's 118, the sketch. At the maximum field of view, this ray coming from the edge of the screen, the maximum field is deviated to the eye. On this ray deviation angle is an important factor. In fact, the trick here to tilt the lens, the display, is to be able to do some wide field of view, wider field of view headset without having to make an image with a very strong ray deviation. So here the ray deviation might be up to 60 degrees or 70 degrees ray deviation of this ray at the maximum field of view made by the lens. The existing products are quite large because they are using two large display of 5.5 inch as explained before. But there is also another, so it's more bulky, but there is also another thing is that because the image quality is very important in the straightforward direction when we look just in front, and because we make this tilt of the optics on the display, we decrease this optical image quality, and because the image optical quality is better on the optical axis. So this is an additional issue for the tilted counted optics architecture. Now let me present you multipath or architecture or field path. So with this picture which show you the inside of Panasonic headsets, it was a prototype in 2017, so we see that we put our eyes there. There is, instead of one lens, there is two lenses, and we see that the two lenses are close together. One is more for let's say the front view, the front field of view, on the little ones on the side are for the peripheral views. So here what we do with multipath is that instead of having one lens on one display, we might have two lenses on two display, or three lenses, or three display, and so on. We can even have an array of lens on an array of display. So of course it may cost more to have more display. It's one thing. Want to have more lens, this is one thing. If we have only two lens on two display like this Panasonic headset, we might be we might be a little bulky, but we don't have we might not have much gain in terms of compactness. But when we look at if we put an array, for example, of lenses, the lenses could have a shorter focal length, so we can have a gain in thickness of the display. Maybe we can be more compact. So, but the thing is that the issue with this architecture is that the eye is very sensitive to something who change in the image, to very little difference, and when the eye look at a portion of an image, the light which comes in his eye might come from different lenses on different display. So he might notice that something go wrong, that there is some kind of inhomogeneity somewhere. Also, the eye position moves when we look in different direction. On the eye position could vary from one person to one person, or when you take one day your headset, on another day your headset. So this thing makes it very difficult, in fact, to tackle this thing of image discontinuity. And then, yes, let's speak about, I come back just there, just to say the advantage of this, another advantage of this architecture is that if you look at the sketch in the middle, you see that there is, if you, for example, if you use an array of lenses there, many lenses, you see that the maximum field of view, the ray deviation of the maximum field of view could be very small. And this is interesting because it makes it's very much easy to make good image quality when the ray deviation is small between the maximum field of view on the incidence of a ray on the display side. So this is still the same trick than for the tilted optics. And then the curved architecture, so we still have the same trick, it's always the same. The fact to have something curved for the display makes a small ray deviation at the edge, because the screen edge is very near from the field of view direction, and this is always the same trick to make it easy for the lens design. But okay, you should have to have some custom optics, and also if you want only one lens on only one curved display, it could be also quite bulky. Some university have tried to make this, so it could be a bulky design. But to make it more compact, there is this interesting prototype from Time VR in 2020, where they use this kind of curved display, and in addition they use this multipath architecture, because we can combine everything. So on here it has been made a quite compact architecture. Still, you still have this curved display, which will be custom, but there is another issue, is that there is still this issue for the multipath architectures, the fact that you should have no discontinuity in the image seen by the eye when the eye looks in a direction, but also when the eye moves across the field of view. So yes, so about existing products. So there are existing products with this counted optics and for eye field of view headsets, and for the multipath, for the curved display, they are at prototype stage. Yes. So now let's come to our architectures. What is our architecture compared to the other eye field of view architecture? In fact, in our architecture, as you can see in the sketch in the screen, at the center of the screen, we have a big ray deviation. We have a big ray deviation there. This is something that everyone first with the other architecture has tried to avoid, because it's very difficult to make an image if you have a very big deviation because of optical aberration rules. So they have avoided this by curving the display, by using different lenses, or by tilting the display, or a combination of that. Here we do nothing of this. We keep the screen on the lens not tilted. We use only one screen flat perpendicular to it could be perpendicular to the optical axis. So on the ray deviation is big on we achieve to make it with a big ray deviation. So this is the big difference. If you look, for example, in astronomy, in eyepiece of astronomy, you can have maybe some standard field of view of 70 degree, a low field of view of 30 degree eyepiece, and if you look through patterns, you might find some field of view up to maybe 120 degree. So it's larger, bigger eyepiece, maybe 2-inch, 3-inch image, and often very long on many components. So we see that it's very difficult to. It could be very difficult to make this on this kind of high ray deviation with wide field of view without exotic architecture has not been made previously. So this is our architecture. So we have achieved the first prototype in 2013. So it's on the right picture. So this architecture, it was with 180 degree field and with a 6-inch screen. We make it compact, of course, and we plan to do beginning of 2024. So here you just have to change in the date, 2023 and 2024. Yes. Yes. So we plan to do some improvement with a 5 or 6-inch display for both eye. 180 degree, and we will make also some glasses prototype lenses for 180 degree on a display about 2-inch size, so one display for both eyes, so 2 display. Just to recall the concept from what we have started to go there. So the idea is that we want to have a lens which fits the orbital position of the eye. So it should be quite near, not too near, of course, because we need some eye relief, so to be comfortable, but it should be quite near and curved in order to gather the maximum field of view we can get. So this is from where we started to arrive there. So yes, in this picture you see again a vision of the lens, of the rays, and here it's with larger screens. So here you can see that we have a very strong ray deviation. So the ray deviation in our architecture, it could be 60 degrees, 70 degrees, 89 degrees, 90 degrees. It could be very, very large. So this is why we achieve to stay on axis and with only one lens and one display. The display could be small. Yes, so as said before, maybe you might use one display for both eye, or maybe 2 display, 1 display per eye. So what we offer now to continue with this technology we really like. We offer we are open to different things. So for licensing patents, also for some patent session, but we also propose some research and development services in optical engineering, optical prototyping, to customize your full vision eyepiece for XR device, and we will do also IP improvements. because we will continue to work on this XR eyepiece device, and also for other eyepiece application for our full vision eyepiece. And we're open also for startup creation or XR headsets company. So this is something also possible. So everything is possible today. And so I give you my contact, and so you have phone number, email. So please tell me if you have liked this presentation, and if you have any remark or any information to transmit to me, I would be very happy to receive you. And yes, and if you are interested in anything there, yes, please feel free to contact me. Yes, so thank you for listening to me. For me, it was really a pleasure to be there with you and to communicate on our very new full vision small form factor eyepiece. I hope you have liked it, and I hope I will give you some news about this in future conference. Thank you. Bye bye.